Hello everyone. In today's topic we are going to discuss about the conducting system of the heart. So this is the second topic of the cardiovascular system. So as we have discussed about the anatomy and physiology of the heart, I'm just going to brush it up. Okay. So this is the structure of the heart. So the superior and the inferior vena cava, this is collecting the deoxygenated blood from all the parts of the body, and they is transmitted to the right atrium, and through the tricuspid valve, the right atrioventricular valve, it is being transmitted to the right ventricle, and from the right ventricle deoxygenated blood is being carried by the right and the left pulmonary artery to the lungs for purification, and from the lungs for purification it is being purified, and all the oxygenated blood is carried into the left atrium, the left atrium, through the left pulmonary veins and the right pulmonary veins, which all the four open into the left atrium, and from the left atrium it is moved on to the left ventricle through the bicuspid valve, and from the left ventricle through the aorta it is taken to the all the parts of the body. So this is the if you're not able to understand it, you can just watch my previous video of the anatomy and physiology of the heart. Okay, and this is the flow of blood through the heart. All the oxygenated blood, it is being carried to the right atrium and then to the ventricle, and from the ventricle to the right and the left pulmonary artery, and the oxygenated blood is carried from the pulmonary veins to the left atrium and to the left ventricle, and from there to all the parts of the body through the aorta. Okay, and there are mainly two circulation, as we've already discussed. It's a pulmonary circulation and the systemic circulation. Systemic circulation, it's happening between the heart and the body parts, and the pulmonary circulation is happening between the heart and the lungs. So all the oxygenated blood which is being carried to the lungs for purification, and from the lungs to all the deoxygenated blood is carrying to the lungs for purification, and then the purified, that is the oxygenated blood, is being carried to the heart, and from the heart all the oxygenated blood is carrying to all the parts of the body, and from in the tissues the exchange of gases being taking place, and all the deoxygenated blood is again carried to the heart, and it is a cyclic process. Okay, so the thing which is happening inside the between the heart and the lungs is called the pulmonary circulation, and the things which is being happening between the heart and the body parts is called the systemic circulation. This is just an introduction. Okay, and now I'm going to give an introduction about the conducting system of the heart. What is meant by the conducting system of the heart? Okay, the heart is having the property of autorhythmicity. Okay, the meaning of autorhythmicity is nothing need to be initiated. That means the heart doesn't need anything to initiate its own rhythmic heartbeat. Okay, you know that the heart is beating a sound of lup tup. That is the sound which is being created at the closure of the valves. Okay, so the autorhythmicity is it has its own thing that which generates within the heart itself, and it doesn't need anything else to induce that heartbeat. Okay, it means that the heart generates its own electrical impulses and beats independently of nervous or hormonal control. That is, it is not dependent on the external mechanisms to initiate each heartbeat. As I've already said that it initiates its own electrical impulses. So though because of this electrical impulses only the heart is beating. Okay, and there are so many nerves and hormonal controls are there that only increase and decreases the heartbeat, not initiate the heartbeat. Okay, the heart generates its own electrical impulses. So we'll see later about which one is the one which is generating that own electrical impulses to the heart. Okay, and also it is supplied with both sympathetic and parasympathetic nerve fibers, which increase and decrease respectively the intrinsic heart rate. That means the heartbeat when all cardiac, neural and hormonal inputs are removed. So as I've already said that some nerve supplies are there. What is that means? The sympathetic and the parasympathetic nerve fibers are being attached to this heart, so that it can increase and decrease the heartbeat, neither it can start the heartbeat. Okay, for example, if a dog or something is just chasing you, what happens, your heart is beating but suddenly your heartbeat will increase. So because of this sympathetic thing, this the heartbeat will increase. And normally when you are resting, when you are sleeping, when you are doing nothing, the heart is beating, and that is because of this vagal nerve stimulation the heart is beating. Okay, that is being mentioned here. The heart responds to a number of circulating hormones, which includes adrenaline, epinephrine, and thyroxine. So there are some hormones which is also responding. That is this hormones that is being responding to this heartbeat. Small groups of specialized neuromuscular cells in the myocardium initiate and conduct impulses which coordinates and synchronizes the contraction of the heart muscle. So there are small groups of special neuromuscular cells which is also conducting the impulses of the heart. We'll see in later. Okay, so I'm just giving you this diagram for understanding and I'll explain it later. So this is atrial depolarization. I'll explain that depolarization means the contraction of the heart. Repolarization means the relaxation, that is called the returning back to its normalcy, that is repolarization. Okay, the yellow thing is the depolarization. So atrial depolarization means the depolarization which is occurring in the atria. So that is called the atrial. Both the atrium contracts at the same time. That is the atrial depolarization. It begins, and when it is complete, the whole atrium will be contracting. And third one is the ventricular depolarization begins. So when this depolarization, that means the contraction begins, the atrial start to repolarize. Repolarize means returning back to its normal. Returning. Okay, just keep in mind like that. It's returning back to its normal state. Okay, so ventricular depolarization complete. What happens when it begins? This one begins to its normal state, and the ventricular depolarization will occur in the whole area. Okay, so next what happens is the ventricular depolarization begins, repolarization. Then after this full repolarization occurs, and the ventricular repolarization is complete. Okay, the basic concept is atria compress, that means shrink, that means the contracts at the same time, and the ventricles contracts at the same time. Okay, that is the main concept, and they both won't contract at the same time. Only the atrium contract, and then it after it's getting relaxed, the ventricles begin to contract, and when the ventricles begin to relax, then again the atria contract. This is a cyclic process. Okay, that is the thing. So here you are going to see about the difference between the depolarization and the repolarization. Why I'm giving just an introduction about this is hereafter we are going to see about depolarization, repolarization. For that I'm just giving an introduction. Okay, here you can see the blue one are the sodium, the red one are the potassium, the green is the sodium channel, the violet one is the potassium channel, and the purple one is the sodium and potassium pump. Okay, this is the thing which you are going to see. So resting time, when the heart is at rest, what happens? The sodium is having the positive charge and the potassium is having the negative charge. Okay, they are at the different place. When the depolarization, that means what we told, depolarization means contraction. When the contraction begins, what happens? The sodium will come and combine with the potassium. At that time, this place becomes the positive and this place becomes the negative. Okay. And repolarization means the relaxation of the heart. At that time what happens, this potassium is going back into the sodium place. Okay, through the sodium pump it's going back, and this place becomes positive and this place becomes negative. Okay, and backing to the resting potential, and they have to return back to their normal state. At that time everybody goes to their own place. The sodium will go to the sodium place and potassium will come back, and it becomes positive and becomes negative, like how it was in the resting potential. It is being changed. Okay, now we will see this when the heart is at rest. Okay, when the depolarization start, what happens? This process happens. The sodium will come back and come back to the potassium, and the potassium it changes to the positive and it becomes negative. So the contraction starts, and when it reaches the maximum, the repolarization starts, and the sodium will go back, the potassium will go to the sodium's place. So this happens in the repolarization. And this resting potential, okay, the resting time, it takes 10 milliseconds, okay. Between this depolarization and repolarization, this resting potential takes 10 milliseconds. What happens at that time? Everybody goes to back to those original places and the charge will be changed, okay. This is what happens. Now we will see this. The movement of the cell membrane potential to more positive value, okay. In depolarization, it becomes, which cell is coming, it becomes sodium is coming, and it becomes to become to a positive value, and here it changes to a negative value. Here it changes to a negative value. The inner membrane becomes less negative. What happens to the inner membrane? It becomes less negative. Here the inner turns the inner membrane negative. It becomes less negative and it turns it negative, okay. Increases the membrane potential, because in depolarization, what happens, so much of energy is needed to contract. If you are having a balloon or a squishy ball in your hand, and if you are pressing it, some energy is needed, okay. So what happens, the potential, the energy becomes, that means the strain that is being increased in the membrane, okay. So what happens in repolarization? Decreases the membrane potential, restoring the resting membrane potential. Because in anything that had to be get back to its original state, if a balloon is being squished and if it is being returning back to its original state, if you are opening our hands, no energy is needed at that time. So that is what is being mentioned, okay. Facilitates the firing of an action potential, prevents the firing of an action potential. So for the heart to get contract, some firing, some potential is being needed, that is being mentioned. So what happens here, it prevents the firing of an action potential. So caused by the opening of the sodium channels and caused by the opening of the potassium channels, okay. Depolarization, sodium channel is being opened. Repolarization, potassium channel is being opened. Results in the stimulating effector organ such as the muscular contraction, does not result in the stimulator of an effective organ. So what happens in the contraction, the muscles are being tightened and it being contracts. So that happens in this depolarization. So just give an introduction, okay. Now we are going on to the main topic, that is the sinoatrial node. This is the main conducting system of the heart, okay. The SA node is a specialized cell which lies in the wall of the right atrium near the opening of the superior vena cava. So the impure blood is being carried by the superior and the inferior vena cava. That is, the SA node is being just situated near the superior vena cava, okay, that is being placed here. So the sinoatrial cell generates a regular electrical impulse. These are the one which generates regular electrical impulses. Because of this only the heart is being functioning. They discharge electrical impulses, that is the depolarization. What I told, that the electrical depolarization means the contraction. So they discharge electrical impulses regularly, which is between 60 to 80 times a minute. So it generates electrical impulses within 60 to 80 times a minute. This depolarization is followed by the recovery, that is the repolarization, but immediately their instability leads them to discharge again, setting the heart rate, okay. So first what happens is the depolarization, that means the contraction happens, and then followed by the repolarization, that means getting back to their original state happens. What happened? It happens all of a sudden, within seconds it happened. So that's an instability, and that start them to discharge again, okay. This makes the heart set a heart rate, okay. SA node are the main thing which sets the heart rate for a person. So SA node is called the pacemaker. It can be asked for 1 mark or 2 mark, or it is a very important node. SA node is called the pacemaker of the heart because the SA node discharges faster than any other parts of the heart that normally sets the heart rate. So it is the one which sets the heart rate, and it is also called as the pacemaker of the heart. The rapid firing of the SA node triggers the atrial contraction. So there is a rapid firing of the SA node that which helps in the contraction of the atrium, okay. This is all about the atrium. Now it's about the atrioventricular node. In the wall of the atrial septum, AV node is situated which is a small mass of neuromuscular tissue. So this is the AV node. It is a small neuromuscular tissue, okay? And the AV node transmits the electrical signals from the atria into the ventricles merely. So what is the purpose of this AV node is it transmits the electrical signals from the SA node to the AV node, and from here it is being transmitting to the bundle of His, the Purkinjee fibers everywhere. Okay, this is the transmission is the main purpose of this AV node. There is a delay when the AV node passes electrical signals. The electrical signals take 0.1 seconds to pass through the ventricles. So what happens when the AV node is passing the electrical signals? So at that time there will be a delay of 0.1 second. So actually the whole cardiac cycle itself, it's 0.8 seconds. In that there is a delay of 0.1 second. There is a delay when the AV node is passing the electrical signals into the ventricles. Okay, so this is the one which is transmitting the electric ventricles. This delay allows the atria to finish contracting before the ventricle starts contraction. So this 0.1 second delay the AV node which makes helps in finishing the contraction of the atrium. So already we have seen one diagram in the beginning. So you can see here. So this 0.1 second delay, that means here the atrium is contracting, complete contraction of the atrium happens, and this relaxation is happening now. So between this and this 0.1 second difference helps the atrium to relax when the AV node is passing the electrical signals to the ventricles. Okay, this is what meant in that passage. Okay, the intrinsic firing rate, the AV node is a secondary pacemaker when there is a problem with the SA node, or when there is a problem in the transmission of impulses from the atria. So if the SA node is not functioning properly, or some problem is happening while the transmission, then at that time what happens, the AV node acts as the secondary pacemaker. This is also an important note. The pacemaker is the SA node and the secondary pacemaker is the AV node. Okay, the intrinsic firing rate of the AV node is lower than that of the SA node. So the SA node has a firing rate of 60 to 80 firing rate per minute, and the AV node has a firing rate of 40 to 60 firing rate per minute. So this is the primary pacemaker. So it has the property of 60 to 80 firing rate per minute, and it has the 40 to 60 firing rate per minute. Okay. So next is the atrioventricular bundle, or the bundle of His. So this is the thing. Okay, so let's see what happening. The bundle of His is a mass of specialized fibers which originates from the AV node. So it is originating from the AV node. This is the bundle of His. Okay, the bundle has the left atrioventricular bundle and the right atrioventricular bundle. Two bundles are the present. So this is the bundle. Okay. So the AV bundle crosses the fibrous ring which separates the atria and the ventricles, and then crosses the upper end of the ventricular septum, and it divides into the right and the left bundle of branches. As you can see, it crosses, this is a septum of the heart. Okay, so it crosses the fibrous ring which separates the atrium and the ventricle. This is the one which separates the atrium and the ventricle. So it crosses that point, and from there it passes through the ventricles, that it divides into the right and the left bundle of branches. Okay, the branches breaks up into fine fibers called as the Purkinjee fibers. Here you can see the small nerve like endings, that is the dividing from the bundle of His, that is called as the Purkinjee fibers. So the electrical impulses from the AV node is transmitted to the AV bundle branches and Purkinjee fibers to the apex of the myocardium, from which the wave of ventricular contraction begins, then moves upwards and outwards, which pump the blood into the pulmonary artery and the aorta. So what happens from the SA node, all the electrical impulses is being transmitted to this AV node, and from this AV node what happens, it is transmitted to the bundle of His, and from here it is transmitted to the Purkinjee fibers, and then all the ventricular contraction begins. So as we saw in that on the diagram, So from here it slightly, when the atrium is repolarization, that means when the atrium is relaxing, the ventricle starts to contract and it begins, and it will transmit it from the lower part, it will be transmitting, and when it contracts, what happens, the blood will be pumped to the pulmonary artery and the aorta from the right and the left ventricles. Okay, so this is about the bundle of His or the Purkinjee fibers. And last one is the nerve supply to the heart. So anything that is functioning, that needs some supply, nerve supply will be there. So in the heart there is a nerve supply. So we'll see what is that. The heart is having an influence by the autonomic nerves, that the sympathetic and the parasympathetic, which originates in the cardiovascular center in the medulla oblongata. So from the brain, the medulla oblongata, what happens, there is a influence of the autonomic nerves are being present there. What is that? The sympathetic and the parasympathetic nerve. So what is that? The vagus nerve, that is the vagus nerve which is being present, that which is a parasympathetic nerve, supplies mainly the SA and the AV node and the atrial muscles. What happens? There is a vagus nerve, it's being supplied, the from the medulla cranial nerve, the vagus nerve, that is being supplying the heart, that means the SA node, the AV node and the atrial muscles. The vagal nerve stimulation reduces the rate, force of the heartbeat and the rate at which the impulses are produced. So the vagus nerve is the main one thing which helps in the reduction of the heart rate, the force of the heartbeat. Everything is being controlled by this vagus nerve. So the sympathetic nerve, so this is a parasympathetic. So what is the sympathetic one? The sympathetic nerve supplied by the myocardium of the atria and the ventricles, the SA node and the AV node. The stimulation of the sympathetic nerves increases the rate and force of the heartbeat. What happens, for example, when as I already told this example, when a dog or any unusual circumstances, or somebody is following you, or you want to run, or you're an athlete, you want to run or something, what happens at that time, the heart wants to pump more and some more energy and more blood supply, nerve supply, everything should be there. At that time what happens, sympathetic nerves, it helps in the supply to the myocardium of the atria and the ventricles. This is supplying the blood, and the SA and the node and the AV node stimulation will be happening, and it increases the heart rate and the force of the heartbeat. Everything is being increased. So this sympathetic nerve supply, it happens only when we are in flight-fright reaction. At that time only the sympathetic happens. This parasympathetic happens when we are at rest, when we are sitting, standing, lying down, everything. When we are at rest, what happens? This parasympathetic nerve stimulation happens. That is through the vagus nerve it is happening. Okay. So this is all about the conducting system of the heart. So far we have discussed about the what are the nodes, AV node, SA node, the bundle of His Purkinjee fibers and the nerve supply to the heart. So in the upcoming sessions we will see about the how we have to interpret the ECGs and everything. And so many, it's a vast topic, so I made it into little small topics. So if you have any doubts regarding this conducting system of the heart and the anatomy and physiology, you can post in the comment section below, so that I'll be able to answer your doubts. So thank you so much.